The nice thing about similar solids is that ratios come into play, and if ratios come into play, so do proportions. So let's talk about these ratios. Now, surprisingly enough, two of the ratios are the same as similar figures, the scale factor and the area ratios. So let's look at these things. Let's look at the scale factor of these two similar figures. Notice that 4 over 6 is equal to 2 over 3, and that's also equal to 3 over 4.5. Everything reduces to 2/3. So our scale factor is 2/3. In order to find the area ratio, we're going to need to find some surface areas. So with the first one, the surface area is the perimeter of the base times the height plus 2 times the area of the base. And that gives us 52 square units. The next one, very similar. The surface area is going to be perimeter of the base, and the height of the prism is 6. The area of the base times the 2, because there are 2 bases. Add those together, you get 117. So our area ratio is going to be 52 over 117, and that reduces to 4/9. So our area ratio is 4/9. Now, to find the volume ratio, the volume is the area of the base times the height. So the volume is 24 cubic units of the smaller prism. Of the larger prism, it gives us 81 cubic units. So our volume ratio is 24 over 81. Divide top and bottom by 3, you get 8/27. So our volume ratio is 8/27. Remember with similar figures how the area ratio was the scale factor squared? Notice, what is 4/9? 4/9 happens to be 2/3 squared. What happens if you cube the scale factor? 2 cubed is 8, and 3 cubed is 27. So here we go. Our ratios are very simply this. If the scale factor is a over d, then the area ratio is a squared over d squared, and the volume ratio is a cubed over d cubed. Very simple. If you remember the exponent on the units, you will know how to convert a scale factor to the appropriate ratio. So let's try this. So the two cylinders are similar. Find the scale factor of the smaller cylinder to the larger cylinder. Well, what we're given is the volumes. So let's go ahead and write a volume ratio. The volume ratio is 686 pi cubic inches over 1,458 pi cubic inches. Notice that the pi's reduce out, and we can also divide everything by 2. So that's 343 over 729. And that seems really ugly and everything, but it's not really as bad as it looks. Remember that the volume ratio is just the scale factor cubed. So we want to go from this volume ratio to a scale factor. How are we going to go from a cubed over b cubed down to a over b? Do you remember how we undo a square with a square root? There's also a cube root, and it undoes a cube. Now, if you're using one of our calculators at school, you will notice a math button. It's 2 buttons down from the blue button. And if you press that, your 4th option down is the cube root button. So you can press that, and presto, this cube root symbol appears in your calculator. So now we can take the cube root of 343 over 729. Okay, and the cube root of 343 is 7, and the cube root of 729 is 9. So the scale factor is 7 over 9. So notice how we did that. We just wrote the ratio with what we were given, in this case the volumes, and then we undid whatever the exponent was on the scale factor. In this case, the volume ratio is the scale factor cubed, so we undid that with a cube root.